Yeah. Our test scores are posted for that logarithms UCA. If you didn't like your score, you can come in and do a retake. We're not going to pass those out just because in other classes we've heard rumors that people have been taking pictures and sending them off to everyone else for people to see, and we just don't want that with this quiz. So if you want to see the test score, you can come in and Mrs. Anderson and I can show you. But that's kind of what we're going to go with that one. Okay? Yeah, if you don't like your score, come and do a retake. That's totally fine.
I got 2%. This is 55%.
Alrighty, y'all. So moving on to rational functions today. So what we're going to be talking about. So there's kind of a couple different approaches that we can take with rational functions. The first one, kind of a helpful. Whoa! It'd be helpful if I showed my camera. That'd be helpful. Monday morning. There we go. All right. So rational functions. The first thing that we need to talk about is the parent function. So the parent function of a rational function looks something like this. So here's my XY table right here. In the graph, there's a horizontal asymptote at y equals 0. A lot like how in exponential equations, do you remember how there's that horizontal asymptote at y equals 0? The same type of thing is going on here. Okay. There's also a vertical asymptote, one going up and down, at x equals 0. And then the graph itself looks like this with two different branches. Okay. This is where it's at. Okay. And I'm just going to write in for notes. There's a vertical asymptote at x equals 0, and then there's a horizontal asymptote that's VA and HA. Vertical asymptote, horizontal asymptote. It's mathematical shorthand, so you don't have to write it out every time. And there's that horizontal asymptote at y equals 0 as well. So that's kind of what's going on here, and that's how every graph starts. I always think it's helpful to always start off with the vertical and horizontal asymptotes and figuring out where those go. And from there, the rest of the graph is pretty easy to figure out. Okay? So, as we're going on to, like graphing some of these functions, comparing them to the graph itself. So, going down here, let's just kind of think about where these things are going to go. So you guys know a lot about graphing. Every section of this book has had stuff about graphing. So what do you think this x plus 4, what do you think this plus 4 is doing?
Moving it left.
Yeah, left how many?
4.
Yeah, left 4. Whoa. Left 4. Now what do you think this negative 2, what do you think that does?
Down 2.
Yeah, down 2. Down 2. What do you think this 3 does? Stretch. Yeah, it'll be a stretch.
Yeah, that's fine.
Vertical. My bad. I know that gets a little small there. Vertical stretch. Stretch. What do you think this negative's doing here? Yeah, it's going to be a reflection. Reflection. Over what axis? X or Y? Over what axis? Yeah, over the x-axis. It's over the x-axis because it's up by this 3. If it was over the y-axis, it would be down here by the x plus 4. But really with rational functions, it's kind of in good form to always put the negative in the numerator, just for your FYI. You won't see a lot of over the y-axis in rational functions in general. It's mainly over the x. It's not unheard of. It does exist. But you'll see mainly over the x-axis with rational functions. Okay? So let's figure out where our vertical asymptotes is going to be and our horizontal asymptotes are going to be. Okay? So I like to kind of figure out where these go. So do you guys see how the vertical asymptote and the horizontal asymptote meet at 0, 0? You guys see that? So I kind of like to plot my horizontal and vertical asymptote based off that. So I said we went down 2 and left 4, right? So I'm going to start at 0, 0, and I'm going to go left 4, 1, 2, 3, 4, and down 2, okay? 1, 2. So no, I know that's kind of where they have to meet. So where's my horizontal asymptote at? Where's that at?
Through the point.
Yeah, through the point at y equals, yeah, -2, right.
Because you went down to.
Yep, I went down 2. That's how I know. Yeah. And my vertical asymptote, where's that going to be at? X equals,
-4.
yeah, -4, right. Good job. Right. So now that I got my asymptotes in place, I can plot my graph. Okay. So I just make an XY table. Now, with graphing these guys, you don't need to go into rocket science, really. I like to pick just 2 points. I determine my points because based off of I need to be on either side of the vertical asymptote. Okay? So do you guys want to pick a point on this side? Do you guys have anyone that you guys particularly like?
8 is 8.
Ooh, -8?
Yeah.
Okay.
-8 is
-8 and one over here?
6.
6? Okay. We can do that. I need to go get a calculator really quick. So kind of plugging these guys in. I plug in -3 divided by, so x, I'm going to start off with -8. -8, what is it, +4? Now the parenthesis here is really important because if you don't have the parenthesis, like the calculator will get confused. So you need that there. +4. Now I need to close my parenthesis and I -2. And my answer is -1.25. So there's that one. Now let's plug in 6. I can hit the up key, and that'll get me up into this equation again. Okay. Delete that, and I put a 6 in. Now I get a -2.3. There we go. So now I'm just ready to plug those points in. Okay. So at -8, I'm at -1.25. So like right here. Okay. And at 6, I'm at a -2.3, which is like right here. So now I can kind of plug my branches in. So the way the branches are going to go, they're going to go right along the vertical and horizontal asymptotes, and they're just going to sit right in there. Okay?
Yeah.
It's going to look like that. It's going to go right along the vertical and horizontal asymptotes. So over here, we're going to kind of do the same thing. It's going to go right along here. It's going to go down this way. Okay? These two things are called the branches of the graph, and they sit right along the vertical and horizontal asymptotes. They kind of make a corner. So let's go back and think about our original function. So our parent function sits like this. We said it flipped. So does that make sense? That this branch flipped up here, and then this branch flipped up there? Because we said it flipped over the x-axis. Does that make sense? Yeah? Do you guys see that? Yeah. It's kind of nice only plotting 1 point on this one. Yeah?
Those arrows are just there, they're not when those certain numbers are.
What ones?
Those arrow thingies.
Which ones? The red lines or the black line?
The black one.
Will they go through the
It's
one?
just there.
Yeah, they have to go through the 1 point, and they go along the asymptotes. That's what you need to draw in. You don't need to pick a million points on these. If you were working for NASA, yeah, you should. But we're in Algebra 2, so.
Why do you need to work for it?
What?
Why do you need to do that mini for NASA?
Because NASA works with a lot of precise measurements, and picking one point on either side of the vertical asymptote isn't very precise, but gets the job done probably too. If you want to pick multiple points, you can. Go for it. Fine by me. But that's what we need to go with. Any questions here? Okay, if not, let's move on to the next one. So what does this -1 do? What's it going to do?
Not right, right?
Yeah, it's going to go right 1. Right 1. And what's this +5 doing?
Up 5.
Yeah, up 5. Good job. Up 5. So now let's figure out where our vertical and horizontal asymptotes are going to be. Okay. So we said it went right 1. So starting at the point 0, 0, I'm going to go right 1. And then it also said it went up 5. So, whoa, I went left. So this is right. Right 1. Now we're going to go up 5. 1, 2, 3, 4, 5. So it's going to say right there. Okay. So along what line is my horizontal asymptote going to be? Y equals 5. Right. Y equals 5. Now where's my vertical asymptote going to be? At x equals 1. Right. I can just draw that bad boy in. Okay. So there's my vertical and horizontal asymptotes. Okay. Now I'm ready to make my XY table. I generally like to pick points close to the vertical asymptote just because I think it's easier. So is there a point that's close to the vertical asymptote that you guys want to pick on the left-hand side? Of it? Over here? A point over here that you guys think is particularly easy? 1? Yep. Oh, wait. You can't pick 1.
Yeah, so a
We
lot of
can-
students ask me about that too. They're like, what numbers do you pick? See this line? You just have to pick any number that's to the left of this line. Any number over here. And then you have to pick a number that's to the right of that line.
Negative 1? That's the number I heard first.
Yeah, I heard -1 and -2. Yeah, any of those.
Either or will work. I just heard -1 first. Now, now we just need to pick a point over here. Is there one over here that works for you guys? 4. Yep, we can do 4. That works. Yep. Okay, so now we just plug into our calculator. 1 divided by, now I have to remember that parenthesis. -1 minus 1. Close the parenthesis. Add 5. And that gets me positive 4.5. Okay? 4.5. Now, remember I can just hit this up key, and that gets me back into our original equation, so we don't need to type it all out. Hit the delete button there, and then plug in a positive 4. And I get 5.3 repeating. 5.3 repeating. So, now I'm ready to plug in my points. So at -1, I'm at 4.5. So that's like right up here. And now I can just kind of graph my branch. And it goes right along the horizontal and vertical asymptotes. That's how it goes. That's a bad little curve there. I'll fix that. There we go. Okay, now I'm ready to try number 4. 4, we're at 5.3. Yeah, it's like right here, right? Yeah. And it looks just like this, right? Yeah. It's going to be up top, up here. Really, this plugging in the points really kind of helps you figure out what kind of quadrant you're going to be in. That's why you do it, to figure out where you're going to sit. Okay? Any questions on this one? No? Okay. So now we're going to switch gears a bit. You're also going to get rational equations in some other forms as well. So generally a function of the form like f of x equals p of x over q of x. That's a rational function. So you can think of this p of x and q of x as like two different types of equations. Like they can be polynomial equations. Generally, that's what they're going to be. That's a lot of what you guys are going to deal with, different polynomial equations. So that's all it's going to be. So the first kind of step really is to simplify the fraction. So that means like look for like terms. Look for like terms. Okay. That's really what we're going to do. Finding the y-intercept. Look for like terms and cancel. So finding the y-intercept, all we're going to do is we're going to replace all the x's with 0 and simplify. That's all we're going to do with the y-intercept. Okay. To find the x-intercept, we set the numerator equal to 0. That's what we do. That kind of makes sense because where the denominator would equal 0, we would end up dividing by 0, which is that illegal? Dividing by 0? No, it's something we need to avoid. Okay. So to find a vertical asymptote, though, we do set the denominator equal to 0. That's to help us avoid like the whole dividing by 0 business. Okay. We have a way to compensate for that. That's how we find the vertical asymptote. And we find the horizontal asymptotes by following the rules below. Okay? So when the degree of the numerator, now remember, how do we find degrees? You guys remember? Remember how we find the degrees of those asymptotes, or find the degrees of a polynomial? So if I had like x squared plus x over x plus 1, what would be the degree of my numerator? 2, right. What's the degree of my denominator? 1, right. So remember, the degree is just the biggest exponent. That's what it is. Okay? So when the degree of the numerator is greater than the degree of the denominator, the horizontal asymptote does not exist. That basically just like DNE, just honestly, it means does not exist. That's what it is.
So like the one he just gave you on the side, x2 over the x to the first, see that one had more x's in the top, so you say it does not exist. The horizontal asymptote does not exist.
Mm-hmm. Really,
You're going to practice more on the back. He's just giving you all the rules right now so that you know how to do all of them step by step when we do the ones on the back.
What?
Just kidding.
What was that? Oh, okay. All right. So really what that can kind of look like is just like x to the 5th over like x to the 3rd. So do you guys see how there's like more x's in my numerator than there are in my denominator? So that's what that kind of situation looks like. Now when the degree of the numerator is less than the degree of the denominator, that's going to be, the horizontal asymptote is going to be at y equals 0. So that's just going to look like x to the 4th over x.
No.
Oh, my bad. I got that flipped around. That's just going to be x over x to the 4th. So do you guys see how there's more x's in my denominator now versus my numerator? Do you guys see that? Yeah. Yeah.
Yeah, if there's more x's at the bottom, then
Yep,
it'll
more
be
x's on the bottom than in the
y
numerator.
equals 0.
Yeah. Now, when the degree of the numerator equals the degree of the denominator, basically what that's just going to be, it's just the lead coefficients in fraction form. Or sometimes this is referred to as the ratio of the lead coefficients. That's what it is. I think this wording is just a little bit better. Again, we'll show an example of that. That's what it's going to look like. Okay? And now we need to identify any holes in the function. Basically, a place where there's a hole in the function is where like terms canceled. Okay, so that would look like something like x plus 5 over x plus 5. So do you guys see how there's an x plus 5 in the numerator and an x plus 5 in the denominator? these two terms would cancel, and there would be a hole. Okay? Does that make sense? That's what it's going to look like. It's going to look like that kind of situation. Okay? Any questions here? We're going to move on to the back for some examples here in a minute.
Yeah, we need examples.
Yeah. No. Yep. You're going to get some.
It says
Yeah.
like terms canceled.
Yeah.
You
Cancel.
spelled it wrong. Canceled.
Oh.
CANCEL.
I'm driving the struggle bus this morning. That time changed. Cancel.
CELED.
Yeah. I don't know.
Yeah.
Canceled. Whatever.
There you go.
Close enough. They cancel. Okay?
Yeah, like when something cancels in the problem, then you're going to get a hole. You'll see.
Yeah.
We're going to practice some. It's like getting all
Yeah.
these rules listed out, and then we'll use them.
Yeah. Yep. Okay. All right. So let's go on to the back. So the first thing that we're asked to do, the first thing that we kind of have to do when we do these is we have to graph. We have to graph it. But the first thing we kind of have to do is look for like terms. So just looking at my numerator, is there something that I can factor out of everything there? Do both terms have something?
They have a 5.
Negative.
Yeah, they have a negative, right. So when I can factor out that negative, so that's just like negative x plus 5, right? Because I factor out a negative, and it'll make both of these positive then. Now just looking at my denominator, is there something that I could factor out of both of these? Yeah, I can factor out an x of both of them. So that's just x over x plus 5, right? Now I look for things I can simplify. Is there something in the numerator and something in the denominator that are the same? Yeah, both the numerator and the denominator have an x plus 5. So they cancel out. So I'm left with, now, when something is divided by itself, what does that equal? 1, right. So it's just left with negative 1 over x. That's what I'm left with. So this becomes the function that I need to graph. Okay? But we do have to do something with this whole. So we take the term that we canceled, x plus 5, and we set it equal to 0. This is going to help us figure out where the whole actually is. And like to figure out the x value of where the whole is going to be at. So if I subtract 5, I get x equals a negative 5. And there's going to be a hole there. Like an actual hole. Like I'm going to put a circle there. That's what it's going to look like. Okay? So now I kind of need to figure out where my vertical and horizontal asymptotes are going to be. Vertical asymptote and my horizontal asymptote. I need to figure out where those two things are going to be. Okay, so my vertical asymptote, if I look to the front, that's going to be where the denominator is equal to 0, right? So, where does x equal 0? At x equals 0, right? That's just where it's going to be at. Set my denominator equal to 0. Now my horizontal asymptote, I have to remember these rules, right? Over here are different cases. I kind of want to look at the degree of my numerator and my denominator. So how many x's are in my numerator? 0. So it just has a degree of 0, right? How many x's are in my denominator? 1. So it has a degree 1. So my denominator has more x's than my numerator. So what rule do I have to follow? Yeah, at y equals 0, right. That's just where it's going to be at. Okay? At y equals 0. So now I can plot my horizontal and vertical asymptote. Okay? I can plot those. What?
But this needs to be on the line.
Yeah,
Yeah.
on the lines. Yeah, on the X and Y axis. That's entirely right. You're right, Gio. Yeah. So now I can pick an XY table. Make an XY table, and I can pick 2 points. This time, I'm just going to pick 1 and -1, just because they're easy. I like to pick those points. Now, I'm not going to plug this into my calculator, because you guys should be able to figure this out. So, if I were to plug 1 in to X, that's just like -1 over 1. What's that going to equal? -1, right. Now I have now when I plug in -1, that's like -1 over -1. What's that going to equal? +1, right. Now I can plug my points in. So at 1, I'm at -1. And at -1, I'm at +1. And now my branches will go right along my asymptotes. Okay. And it looks just like that. That's what the graph looks like.
And then at the beginning, you canceled out that x plus 5.
Oh, yes.
So now you have to look for and put a hole in the graph. Because you solved that
Yeah.
x plus 5 part. So you got x equals -5. So now you're going to go over on the graph to -5 and make it an open circle, a hole.
Yep.
It's weird. You just make a hole
There's
on
a
the
hole
graph.
right there.
You just make an
Yeah.
open circle.
Open circle. Yep. That wasn't a very good
Don't
one.
color it in.
No, don't color it in. That was a
Yeah,
bad
it's
one.
okay. It's just
Yeah.
like go over to -5 and you put an
Yeah.
open circle.
On
Yeah.
the acetone.
It's because he already made
Yeah.
it in pen, but it's okay.
Yes.
Just make
Yeah.
an open like
I
donut
made it in
hole
pen.
circle
On the acetone.
No, on
your
the
black
line.
graph. On
Yeah.
your black graph.
Yep.
Go over to, and some people asked about where -5, it has to be on the x-axis. See, you're on
Yeah.
the x, go over to x, -5, and then just make like an open circle. It's weird. It's kind of a weird thing.
Mm-hmm. Yeah. That's where it's going to be at. Okay? Make sense? Make sense? Any questions on this one? Any questions here? No? Okay. If not, let's go on to our next one. All right? So, first thing I want to do is I want to look for anything that I can simplify out. Okay? So, when I look at these, is there anything that I can simplify out that'll cancel an x term with there? No, there's nothing in my numerator, nothing in my denominator that will really work to do that. Okay, so now I kind of want to look for my vertical and horizontal asymptotes. Okay, so a vertical asymptote and a horizontal asymptote. So how do I find my vertical asymptote again? Set the denominator equal to, check the front side of the sheet. Set the denominator. Yeah, set the denominator equal to 0. So that's just going to be 4x minus 8 equals 0. I add 8 to both sides. I get 4x equals 8. How do I get, now I need to get x by itself. How do I do that? Yeah, divide by 4. When I do that, I'm just going to be left with x equals 2, right? So I can draw that line in. That's where that's going to be at. Okay. Now I need to figure out my horizontal asymptote. I wanted to do that. I kind of want to look at the degrees of my numerator and my denominator. So what's the degree of my numerator? 1, right? Because we look at their exponent. That's just 1 there. What's the degree of the denominator? 1. So the degree of my numerator equals the degree of my denominator. So what does that tell you about where the horizontal asymptote is going to be? Ooh. Is it going to be like the fractions of the lead coefficients? Yeah. So here, do you guys see how this is a 2? This lead coefficient, that's a 2. And then this lead coefficient's a 4. Yeah, it's just going to be 2 over 4. That's where it's going to be at. So 2 over 4, that can be divided, that can be simplified down to just 1/2, right? So y equals 1/2 for my horizontal asymptote. Okay? So at 1/2, I know that's like right here. And then we just draw our line in. That's it. Okay? And there you go. Does that make sense how we found those? Yeah?
Wouldn't your line be further up?
What?
Wouldn't your line be further up if it's the 1/2?
Why?
Now you gotta go to the 1 up halfway.
So you're saying I need to go over to 1?
All the way down.
Yeah. No. Yep. It's just going to be at y equals
Half of
1/2.
1.
That's it. Yep. Half of 1. That's it. Yep. All right. So now I can make an XY table. I have my horizontal and vertical asymptotes in place. So just make an XY table. So is there a point on the left side of the vertical asymptote that you guys want me to pick? 1. I can do that. And on the right side of my vertical asymptote, is there a point that you guys want me to pick? 3? Sounds good to me. So now I plug this into my calculator. And with these, you really have to kind of remember to always have your parentheses in place. Whenever you see an x in your numerator and denominator, just so your calculator doesn't get confused. So I'm going to start off by putting parentheses around my numerator. So this is 2 times 1, plus 1, close my parenthesis, because that's my denominator, and that's my numerator, divide by my denominator, so I have to put another parenthesis, 4 times 1, minus 8, close my parenthesis, that's just a negative 0.75. Now I need to plug 3 in, so I'm going to go up to my numerator, or go back up to my equation. I did that by just hitting the up arrow right here, this one, this key right here. So anytime I see like a times 1, I want to change that to a times 3. Okay, hit enter, and that's 1.75. Okay. Now I'm ready to plug my points in. So at 1, I'm at negative 0.75, so that's just right here. And at 3, I'm at positive 1.75. That's just right up here. Now I can draw my branches in. And there wasn't any holes to worry about this time, so we don't need to worry about those. And then, yeah. That's what this graph looks like. Does that make sense? Pretty quick and easy. Any other questions? There's a lot to remember with these. There's quite a bit of steps. But I like them, not gonna lie. It's very systematic. I like that. Okay. Any questions on this one? Yeah. I like the next one. So remember, the first step is to simplify. So look for anything that you can factor, anything like that. Now, do you think we can factor this denominator somehow? Factor this term? I can't really factor my numerator. Do you think there might be a way that I could factor my denominator? You guys remember how to factor like a quadratic? Yeah, we're going to take that x. You remember it? It's going to multiply to a negative 2, and it's going to add to a negative 1. So what numbers do that?
Negative 2 and 1.
Yeah, negative 2 and positive 1. So really, I'm going to rewrite this just like over here, okay, as in factored form. So that's just like x plus 1 over x minus 2 times x plus 1. Okay? So do my numerator and my denominator have the same thing, something similar in them now?
Yeah.
Yeah. They both have an x plus 1, right? Right? So they just cancel out. So I'm really left with 1 over x minus 2. This is the graph I'm going to be working with right now. Okay? But remember, I need to take the term that I canceled, x plus 1, put it equal to 0. Why do I do that again? Yeah, that's where there's going to hold to be. I subtract 1 both sides, and I get x equals negative 1. Now there's going to be a hole here. That's where there's a hole at. Okay? That's where there's a hole. So now I'm ready to kind of determine where my vertical asymptote is and my horizontal asymptote is. Okay? How do I find my vertical asymptote? Do you guys remember?
No.
Look at the front.
Look at the front.
That's the rule.
Not on the paper.
Oh,
How do you find the vertical asymptote?
yeah, set the denominator equal to 0.
Yeah.
Good job. So I'm just going to do that. So x minus 2 equals 0. Add 2 to both sides. I'm going to get x equals a positive 2 for my vertical asymptote. Okay. Now, how do I find my horizontal asymptote? Do you guys remember? Look at the front if you don't. Yeah, you look at the degrees. So the degree of my denominator, what is that? 1. What's the degree of my numerator? 0, right. So the degree of my denominator is greater than the degree of my numerator. So yeah, my horizontal asymptote is just going to be at y equals 0.
Yeah, like more x is at the bottom.
Yep,
and
more
y
x is on the
equals
bottom
0.
and the top. So I can kind of plot these on my graph now. So at x at 2, I have a horizontal asymptote, or vertical asymptote, excuse me. And at y equals 0, I have a horizontal asymptote. Okay. So that's what that's going to look like. So now I'm ready to make my xy table. Okay. XY table. Does anyone have a point on the right-hand side that's particularly helpful? 3. That one works. Now on my left-hand side, do you guys have a point that you guys want to pick? 1? 1 works. So, plugging this into my calculator, 1 divided by 1 minus 2, oh no, 3 minus 2. That's just going to be 1, right? 1. Yeah. Yep. Now to find, now I need to go 1, so I hit this up key again. So up key, and replace my 3 with a 1. Now I'm going to get negative 1. Okay. So now I can plot my points. Now remember I had this hole at negative 1, so I kind of need to be mindful that over here there's going to be a hole. Over on this side there's not going to be one, so I can just kind of plot my point and don't worry about it. So that's just 3, 1. So at 3, 1, I have that point. Now this is just going to go right along the asymptote. That's how it's going to travel. Now remember I had this hole at negative 1, so I'm still going to plot my point at positive 1, negative 1. And then I'm going to draw my graph in, but whoa, I have negative 1, so I put an open circle. And I keep going right along my asymptote. Okay? And now this side of the graph just goes right down there. So that's how you graph this one. Make sense? Yeah?
Most of the ones you guys just did on the notes, they were ending up see like your branches like this or like this. Like usually the little curved branches are in like diagonal to each other. Sometimes they might have that. I mean, it can happen, but most of the time,
They're going to be diagonal. Yeah.
90% of the time they're like this.
Yeah.
Yep.
Yeah. Most of the time
These
that's
two.
the way they look like. Okay?
You guys are catching on. Just look at the rules on the front and
Yep.
follow all the steps and
Yeah, that'll be helpful. Okay? Alrighty. So, if there aren't any other questions, we're going to get going with our homework assignment. And I'll get you guys started. 1, 2, 3.
How many problems are there?
12.
12.
Can we just do even numbers?
No. Other classes are doing physical assignments. Alrighty, y'all. One minute.
Can I get
How much work that is for a
Yeah.
problem? Yeah.
Yes, we're gonna do all of them.